Good afternoon, everyone. This is ELISA Baum. I'm GridGain's Director of Product Marketing. I will begin in just a moment, but first I need to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me? And let's see here. Do I see some hands? Can everybody hear me? I don't see any hands. Okay.
I can hear you.
Okay, well, that's good. I'll take that. Ah, there's a hand. Thank you. Okay, good. We always have to check. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of this webinar, we will take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on GridGain's blog. In addition, I'll make sure that everyone here gets a copy of the slides as well as a link to the recording within 48 hours. With that said, I'd like to thank you for attending today's webinar. It's Boost Software and Software as a Service with InMemory Computing, and it's being presented by GridGain Systems Director of Technical Marketing, Matt Sorrell. And with that said, Matt, I will let you go. Go ahead, Matt.
Okay. Good morning, audience. Good afternoon, audience, for those of us who are on the East Coast enjoying this unseasonable weather, which makes me happy. And thank you very much for that lovely introduction, Elisa. Okay, so I am going to talk today about boosting software and SaaS with in-memory computing. I may use the term software and SaaS interchangeably. They're kind of, in many respects, the same thing, and I understand that's glossing over a detail. But really, as far as the quest for performance and scalability that is enabled with in-memory computing, to some extent, software and SaaS are very much very similar. Okay, briefly, here's my agenda. I'm going to give this little introduction, then I'll give a slight overview of in-memory computing, what is in-memory computing and why is now the right time for in-memory computing. I'll talk very briefly about GridGain and Apache Ignite, which is the open source version of GridGain, and you know, this is just so to lay enough of a foundation so that we can then discuss our survey and our use cases. The survey is some questions that we asked of people who were using GridGain, and then I'll get into the use cases, which are, I should probably have this written down, but basically I'm looking at how to speed up search, how to build software for IoT management and reporting, and also, I forget what the other one was. Maybe it was high-speed transactions. But anyway, we'll get to them. And now I know from now on I should have my abstract in front of me when I'm giving these. Okay. And so here's my beautiful picture. And I mean beautiful picture, not beautiful self. And I am the Director of Technical Marketing at GridGain. I have 30 years of experience in tech. This is actually more in tech than in marketing. So I started my career in healthcare and then later in financial services. Let's see, what was I? First it was help desk, then network administrator, server administrator, director of IT, VP of engineering, those kind of roles. And then I was at PC Mag. I'm still a contributing editor to PC Mag, covering small to medium business security. I've also written for GigaOM and eWeek and InfoWorld. And so I like to share what I know about technology. There's my email address. You could follow me on Twitter at msorrell, and a lot of what I do or what we do as a company ends up in the GridGain blog. Okay, so I'm probably preaching to the choir if you're here and you're in software and SaaS. Just to set a foundation here. So what's going on in software and SaaS in 2017? So very briefly, we're looking at open source. We're looking at the continuing open source adoption and people actually turning their products into open source projects to speed adoption as well. So there are two sides of it. Software is becoming a more and more important part of the business, and I think the best example I can give of that is you've got a company like GE who's saying things like, sure, we make refrigerators, we make washing machines, we make electric locomotives, but at the same time, now we're a software company. So software is pretty important. And why is that? Because businesses use software and the data that software collects and analyzes to make decisions. While we're at it, data is open. There's more, not all data, but there's more data sharing than previously. And we're talking about streaming data as well. And companies are now moving towards a data lake architecture, which is another important aspect of what's going on. All these things, they require high performance, they require stability, reliability, security is becoming more and more important, and scalability is important too, because we've kind of reached a point where almost everything needs to be web scale. And as a result of that, we're looking at serverless architectures using, heavily relying on virtualization and containerization, distributed systems, and microservice-based architectures. All these things sort of add up to deliver performance, stability, high availability, scalability, things like that. We're definitely seeing a rise in machine learning, and that's also giving rise to a lot of self-service environments. A lot of these are bot-based or just even better interfaces for end users. And we're also seeing a rise in the use of augmented and virtual reality. So what makes in-memory computing really well suited for software and software as a service? So in doing my research for this webinar, I found this great blog post by, it turns out, one of our customers, Workday, right? So this is really summed up nicely. Memory used to be so expensive that everything you had to do as a developer involved using memory as efficiently as possible. But that has changed over time. And it's changed in such a way that we've got in-memory computing coming to the forefront. Again, I'll probably drive this home a million times, performance and scalability. And designing in-memory computing into your architecture and then building your solution around in-memory computing is actually what will enable I would say a ton of use cases, but that might be an exaggeration. All the things that you sort of think you might not be able to do because you don't have the performance and scalability that you need, you'll be able to do it when you're working on data in memory and doing computations in a distributed fashion. I guess I shouldn't say all the things because it's never all the things, many of the things. So another thing is that in-memory computing enables the ability to use data for transactions and for analytics at the same time because you now are dealing with a system that's efficient enough that you don't need to package and ship data off to do reporting at another time. And I'll get into that in a use case later. And in-memory computing enables greater insight, and it enables business users to operate independently and make decisions on the fly. And that's basically the result of increased performance. So why in-memory now? I touched on this a little bit. On the one hand, we've got users demanding real-time interaction, web scale applications. So, greater users want faster speeds, and because of the nature of how we provide software, we are also required to now provide faster speeds at greater scale. Big, huge data sets. I don't know, does big data even have meaning anymore? It's just kind of data at this point. And memory is getting cheaper, so we can actually do all of this work in memory. This chart basically shows the rise of the increase in growth of data, size, and declining cost of memory. So we want to handle more data, and the price of memory is coming down. So let's start working with data in memory instead of on disk. In-memory computing technology market is big. Gardner forecasts it's growing. So what is this, in 2 years? We're looking at $10 billion a year industry. So what is it, 22% CAGR? And that actually looks pretty consistent across the chart. So this is something the market's embracing. Now, there's a difference between an in-memory point solution and a full-featured solution. So a full-featured solution, like what you get with Ignite or GridGain, is really, it's not just a database that's in memory. It's not just caching. It's more than that. So parallelization of computation, SQL compatibility, streaming data analysis. I have a nice slide which I'll show in a second. Basically, we talk about sliding an in-memory layer between applications and your existing data, which is saved on disk. Support for ACID-compliant transactions, as well as support for analytics packages, the whole thing. So this is more about GridGain. It splits up into, we basically have a bunch of grids that work on clusters of machines, and you can have multiple clusters in multiple data centers, and these are the main pieces. Datagrid, that stores data. Actually, you know what? I'm going to go into this in more depth later. I don't want to hit you with the marketing pitch off the bat, so I'm going to keep moving. Here's how one would deploy the data grid, right? You've got your application up top, and you've got your data store on disk at the bottom. And Ignite or GridGain is, we call it an in-memory data fabric. It's a distributed Java-based middleware infrastructure software. So you basically slide it in between your databases, your file systems, HDFS, whatever you have on the bottom, and your applications on top. And I moved my mouse, I'm sorry. And it provides greater speed and scale by moving everything into memory. Memory is much faster than disk, and that's pretty much what you're talking about. Let me build my slide here. Boop. I should have been building it as I was talking. Okay. Apache Ignite. So GridGain is actually a very mature code base. In 2007, we had our first GridGain product, and 7 years later, we contributed Ignite to the Apache Software Foundation. It took about a year for Ignite to become the second fastest project to date, and that's the second fastest growing project behind Spark. So what's the difference between GridGain Enterprise and Apache Ignite? Basically, it comes down to what you would expect as enterprise features, like better security, better network segmentation, protection, rolling updates, I think are huge. So you can update multiple nodes on a cluster without taking the whole cluster down. I actually think that's a cool feature for high availability. Data center replication, up to 32 data centers can be replicated, and better support over Ignite. Anything? Oh, and a better management and monitoring tool. Okay, so I talked a little bit about the different parts of the different components of GridGain or Ignite: Datagrid, Compute Grid, SQL Grid, streaming, Hadoop acceleration, and events processing. And I can go into more detail later, but here you're starting to get an idea of like what does what. I don't know. I'm not one for reading slides to people, so you know, take all this in, and I'm not going to read it. GridGain and Ignite are used by thousands of different companies for a variety of different use cases. I'll get to software and SaaS in 3 or 4 minutes. But basically, we're seeing huge adoption in financial services. And this is because it's a combination of very fast distributed computation as well as the ability to work with data in memory. Huge uses in analytics, mobile, and IoT. And also, we're starting to find a niche in biotech, particularly around genomic modeling and drug discovery. So basically, anything that just needs to be bigger and faster. We're finding that GridGain and Ignite are a good fit. Okay, so we sent a survey to our users, and we asked them a whole bunch of questions, right? So I have picked 4 or 5 questions to share with you. So the top responses to: what uses were you considering for in-memory computing? Database caching, application scaling, high-speed transactions, real-time streaming, and HTAP, hybrid transaction and analytic processing environment. Again, not going to read it all, but hopefully these align with some of the things that you're looking for. Where do you run? So private cloud, on-premise, public cloud, AWS, Azure, Google, etc. So you can really run Ignite or GridGain anywhere you want to. Okay. And what do you use to access your data? Java, SQL, MapReduce, .NET. These are the leaders. So we have API support for quite a few solutions, and then we also have JDBC and ODBC connectivity, basically for everything else. Okay. And then what do you use as your data store beneath GridGain and Ignite? MongoDB. Oh, I left out the part that this survey was given to all of our customers, but what I did was I pulled out the software and SaaS customers. So this is applicable to what software and SaaS customers said they were doing. So MongoDB, HDFS, Oracle, MySQL, you can see the usual suspects. Oh, actually, I should add, since we just mentioned MySQL, ELISA and I just finished a white paper on overcoming the limitations of MySQL with Apache Ignite, and that's available on the GridGain website. We just did that. That just went live on Monday, so I think that's very exciting, and I hope everyone downloads.
Hey, I'll put a link in the follow-up email to that white paper, just in case people are interested.
Oh, great. Thank you.
Sure.
Okay, and how important are these features to your organization? Datagrid? Well, we would expect that. I mean, we're not going to be here to talk about in-memory computing platform without talking about Datagrid, or Compute Grid for that matter. And an in-memory file system, service grid, ANSI SQL 99 compliance, streaming for streaming analysis, support for Mesos, Yarn, Docker, I would add Kubernetes, and using shared RDDs in Spark. So, and these are actually things that I hear over and over again from our customers. All right, so now let's just look very quickly at who are some of GridGain's software and SaaS customers. Workday, which I mentioned before. Advent is a fintech company. They're involved in retail banking. ThingWorx is a enterprise IoT platform. Microsoft, I think we all know, they're using GridGain as the store to drive, well, not the store, the data store, to drive like risk scoring and security ratings across users and applications on Azure. Siemens is using GridGain to power a product lifecycle software. MySIS I'm going to talk about in depth. Optum is they do decision automation and like business intelligence to improve like resource utilization in enterprises. Silver Spring is IoT, specifically smart metering, and the Glue is a financial services middleware. Okay, wow. I think I deserve some kind of prize for remembering all that. Let's look at our first case study. So looking at MySIS. Now MySIS is a financial services software. They have a lot of modules: retail and corporate banking, lending. I'm guessing instead of treasure, that should say treasury. I'm not sure that they're actually managing like pirate treasure. Capital markets, investment management, and enterprise risk. So some of these things are transaction-based, and some of these things are analytics-based. And they have a lot of customers, and they're used by 48 of the world's 50 largest banks. So they faced a challenge, which was eliminating the data processing bottleneck. And I'm sure, actually, most of us are familiar with this idea of the data processing bottleneck. So MySIS was dealing with huge amounts of trading data and accounting data. And at the same time, customers needed high-speed transactions. They also needed real-time reporting. But the problem is that the MySIS solution was architected in such a way that you couldn't get real-time reporting. Everything had to be taken out of the transaction system and go into the reporting system, like, batch processed at night. And this was something they wanted to fix. They wanted to do that by moving to a Java-based IT stack, and use a data lake instead of using like the traditional data warehouse. And also, they had to do all of this in an environment where they're required not just to comply with one government's regulations, but with 130, I think, different governments' regulations. So what they built on commodity servers. I don't know how many servers, and even if I knew, I would imagine it changes probably from day to day. Each, though, has about 256 gigs of RAM, which actually isn't crazy if you think about it. So they work with data in memory for transactions, and then they also pull in market data at the same time and save that. And they do parallel compute processing across the cluster, because they're required to do a lot of calculation-heavy reporting for regulatory compliance. It's actually it's something EU specific. I forget what exactly it's called, but basically, like, banks need to be able to prove almost from minute to minute that they have enough money on hand to support the transactions that they're processing. So there are a lot of variables involved, which is where it becomes important to be able to do distributed computations. At the same time, they also wanted to launch a new product, which is so they had software. They wanted to update the software and turn it into a SaaS product at the same time, and they did that around GridGain and the advantages that in-memory computing could offer. So they have this Fusion Fabric.cloud. It integrates trading systems, like trading systems at the banks and at the brokers with the cloud-based modular components. So I listed all those components, but I don't have to read them. And then I have this, everyone loves these great quotes. With GridGain, we have achieved real-time processing of massive amounts of trade and transaction data, eliminating bottlenecks and enabling us to offer next-generation financial services to our customers. And I think I couldn't ask for a better quote, right? Real-time processing, huge data sets, fast transactions, fast reporting. There you go. So looking at our second customer, we've got, I can't tell you who the customer is, but hopefully soon I'll be able to tell you who the customer is. This is a customer that has over 20,000 information products that they sell worldwide, and they needed a faster search across the products. Not a search for the products, but a search for the information that's inside the products. So this is actually a huge project. So they search now over 5 million different information assets, and they can search over 1 billion different properties. They're forecasting that this is going to grow to over 50 million information assets. So that's a lot of fields to search. And they're also are forecasting that because they're going to be able to offer this service to their customers in a way that none of their competitors or they have ever been able to do, they're looking at about $275 million or greater in annual revenue just from this initiative. And again, the great quote from their CTO, GridGain is the only platform capable of providing the performance and scale we need. Okay, so looking at also IoT management and analytics. So with IoT, we're talking about, the requirements for IoT are performance, scalability, high availability, the ability to work with streams of data as they're ingested into the system, and then having APIs available for analytics. Two GridGain customers are Silver Spring Networks. They have a smart meter solution, and they came to us because they forecasted that so they have this smart meter solution that they then sell to power companies, basically to manage all of their smart meters and all of the analytics that go with that. And they had forecasted that they were going to reach a wall. And so they were looking to go to in-memory computing to overcome that. So they needed performance, scalability, high availability. You don't really want the management platform for your smart meter going down. And then also there's ThingWorx. They're an enterprise IoT platform, and they're looking for performance, scalability as well. What was important to them too was the integration side of it, with GridGain integrating with various other tools like Spark, as well as BI tools like Tableau, and also they needed to have super fast analytics. All right, so now I reached that point. What's in-memory computing? What are people using in-memory computing for in SaaS and software? And now I'm going to talk more specifically about the GridGain in-memory computing platform. The product is technically called the GridGain In-Memory Data Fabric. So you'll see that referenced in slides, but it's more than a fabric, it's a platform. So as you can see, there's there's just a lot of features, and a lot of different ways to access the data that's already in GridGain, a lot of new ways to get data into GridGain, and a lot of ways to access the data that's in it. And we work with a variety of underlying data sources as well. All right, so if we look at the components here, we look at Datagrid, right? So Datagrid goes, well, the whole thing goes between application and data layers, but in particular, Datagrid is where you'll get that immediate performance boost of moving data off of disk and into memory. Datagrid will work with all of your DBMS products, NoSQL products, and Hadoop databases as well. And it's basically a distributed in-memory key value store. Let's see, I hate reading slides. What's really important here? Oh, ACID compliant transactions, web session clustering, and also you have the ability to interact with your data using SQL through the ODBC and JDBC drivers, which I'll get to when I talk about SQL Grid. As far as RDBMS integration, there's support for read-through and write-through, support for write-behind. Eviction policies can be configured as well. And you can actually, we have a neat little tool that you point at your RDBMS and it helps you generate the data cache structures that you'll need in GridGain or Ignite for a data grid. Let's see. So SQL Grid is actually a relatively new feature. We had a good deal of SQL support before, which we've expanded now by adding adding support for DML. So this is a ANSI SQL 99 compliant in-memory SQL grid. Again, so we've got APIs and JDBC and ODBC drivers. So basically, you can point anything at the JDBC and ODBC drivers and be confident that because we're ANSI SQL 99 compliant, you can work with your data through those drivers. Another neat feature is geospatial support for geospatial applications, and it's actually sort of cool. So your SQL commands will get automatically distributed to the nodes that house the data that you're querying. So it's based on where the indexes in your caches reside. And so I guess so my point here is that you're not just querying, like when you query the cluster, it's a distributed query of the cluster. So it's faster than just querying like, it's smarter and faster than it sounds. I don't know. I'm trying to explain it and keep it at a high level. So and of course all these things, the backend, the APIs, the JDBC, ODBC connectivity, those are all things that you'll use when you're developing your software. And so that GridGain and Apache Ignite will work with what you're trying to do. And things like the distributed SQL queries become important because now you know the power and the speed that you're getting. It's actually kind of cool. We have a web console tool, which is a browser-based tool, and you can see how your SQL queries are processed, like which nodes are in the cluster are processing your query. And you can see how shifting data or shifting the query can affect performance. So tweak away. All right, compute grid. I think compute grid is another pretty cool thing because now we're talking about not just clustered data, but clustered compute as well. So parallel processing on compute-intensive tasks. And you can read these features while I take a sip of water. And so, okay. We have an in-memory service grid, which basically lets you control your services, bring your services up and down. There's failover capabilities, load balancing capabilities. Things can be deployed based on time or based on load. And I think a lot of this, will ultimately tie into high availability and reliability strategies. Okay, looking at streaming and continuous event processing, we have the ability to ingest data streams. It's actually super easy. It's like 3 lines of code to start to bring in a stream and start to save it into the data caches in memory, at which point it's available for SQL queries or for use in a BI tool. Oh, I almost forgot when I mentioned that web console and how cool it is. We had we did a webinar last week where it's a detailed walkthrough of the. Sorry, there was some traffic noise, which I'm in New York, so I can't help it. But I said we had a detailed walkthrough of the web console that was done by our product manager. So if you want to go to our website and watch that, you'll see some demos. He had kept it more technical than I am, so it should be very satisfying. Uh, and let's see, that might be all that I have to say about streaming. Mm. So I think what's important here is that um, with our streaming capacity and the ability to work on streaming data in memory, um, you can actually begin to work on the streaming data. You don't have to take the streaming data and start to write it into your data warehouse and then later work on it. So you get a real-time data analysis. Okay. We also offer in-memory Hadoop acceleration, which is used for basically you can get 10x or greater performance with your HDFS file store. And let's see. Oh, I'm on my last slide. Okay. So I guess I will open this up to questions. See, look, Elisa, last time I talked too slow and I went on and on and on, and this time I'm done in time for questions.
You rock. All right, so audience, excuse me, I'm fighting the Texas crud, which is another word for the flu. So anyhow, if you have any questions for Matt, please go ahead and enter them in the GoToWebinar questions panel. And just to let you know, if you are a fintech company, we're doing a webinar on March 22nd about fintech and in-memory computing. So that might be interesting. And then Matt returns on March 29th to a webinar on, I'll just call it the intersection of IoT, your IoT projects and financial services. So if you're in financial service, that might be something to check out. All right, well.
That one's going to be really cool.
Yeah, that one's going to be super duper cool. And Matt is doing it, so you will be highly entertained as well as informed. Excuse me again. Okay, well, Matt, I don't think there's any additional questions. I do want to call one more thing to the audience attention, and that is the In-Memory Computing Summit, which is June 20th and 21st in Amsterdam. It's our first in-memory conference in Europe. We've been having them in the United States, and we will have another one in California in the fall time frame. Early bird pricing is available right now, and if you're interested in submitting a speaker proposal, the due date for that is February 27th, and we welcome all speaker proposals, and we would love to see you there. Okay, well, that's it for my speech. Matt, thank you for a wonderful job. And audience, cool. And audience,
thank you, audience, for listening.
Okay, guys. Well, thank you again, and we'll see you in another webinar.